Hello everyone, we will discuss a problem based on the geometrical optics applications, which is a total internal reflections, which is called the TIR. There is in the diagram we can see that there is a cable which is made up of the two medium N2 and N1, and the value is N1, the refractive indices is 1.5 and then N2 is 1.44. The length of the cable L, which is very greater than the W, as we can see in the questions, and here the ray enters from the side AB and comes out from the side CD. So we have to find the maximum time taken by the ray to exit the plane CD and to find that the time in numerical value. So here we have given this N1 1.5, N2 refractive index as 1.44, and then the length L, which is 9.6 meter. So we have to find the maximum time taken by the light to exit, and it must travel the maximum distance so that it can take the maximum time. So for this it should be incident at a minimum possible angles. That means we will be proceeding for the TIR reflections, total internal reflections inside the cable for this case. So here we have to that there is a theta c, the critical angles through which the light get incident on the N1 and N2 boundary interface, and then we apply the TIR conditions. Then applying the Snell's law at the boundary conditions, we get that this N1 into sine theta 1 is equal to N2 into sine theta 2. This is a theoretically the Snell's law which is followed. And now the numerical part is that there is an N1 into sine theta c. This is the critical angles at which the light incident on the N1 and N2 interface, and this is N2 into the sine 90. As we are dealing with the TIR reflections, so that's why there is a 90 degree for the total internal reflections conditions, and that the ray does not enters into the N2 as the ray get reflected from the N1 N2 interface itself. So from this calculations we get that the sine theta c is equal to the 1.44 divided by 1.50, that is comes out to be 24 by 25. So this is sine theta c, and we can also write this sine theta c as an, this is an hypotenuse and this is an x. So x by d can be also written as an the sine theta c. So this is the 24 by 25. So this is a total d. Now the total light travel, the total length which is traveled by the light inside the tube is, that means we will find the optical distance, that is the 25 by 24 into the 9.6, which comes out to be the 10 meter. That is the 10 meter is an optical distance which is traveled by the light inside the cable. So we get the speed of the light inside the medium as that the c by n1, that means the 3 into 10 ki power 8 divided by 1.5, that comes out to be 2 into 10 ki power 8 meter per second. So the time is the distance by the speed. So the distance is 10 meter and then the speed is 2 into 10 ki power 8. So that's why the time comes out to be the 5 into 10 ki power 9 seconds, which is also written as the 50 nanoseconds. So this is an answer for this part, 50 into 10 ki power minus 9 seconds.